Welcome to the Explainer. Look, if you're the kind of learner who just wants to cut through all the noise and get straight to the nuts and bolts of how our world actually works, well, you are in the exact right place. Today, we've got a really fascinating, highly structured tour lined up for you. We're going to be exploring the universal principles of energy storage. And to help us map all this out, we're bringing in a guide from our source material, a conceptual character known as Commander Energy. Commander Energy's whole mission, it's to show us that the universe is way more interconnected than it might seem on the surface. We are going to break down how completely different physical domains are actually following the exact same rulebook, just kind of hiding in plain sight. Okay, let's dive into this. What exactly does a coiled spring have in common with a massive, heavy water tank? I mean, at first glance, absolutely nothing, right? One is purely mechanical. It's a piece of hardware engineered for, say, high-tension suspension systems or really precise kinetic mechanisms. The other, totally hydraulic, managing immense fluid dynamics and sheer volume. But Commander Energy poses this central mystery to hook us, because from a physics perspective, these seemingly disconnected physical domains might just be doing the exact same thing. Sure, they're wearing different outfits, they're speaking different engineering languages, but beneath all of that, they are performing the exact same mathematical job. It's just a beautifully elegant secret of physics. So, to understand how that's even possible, our source material invites us to metaphorically step inside the energy warehouse. Picture this place as a massive, hyper-organized logistics center for power. Just imagine towering shelves stacked high with kinetic energy, all waiting to be deployed, sitting right alongside enormous vats holding vast reservoirs of potential energy. Commander Energy uses this specific visual framework because it helps us easily grasp how completely disparate scientific fields preserve power. By stepping into this warehouse, we stop looking at individual, isolated inventions. Instead, we start looking at the fundamental roles those inventions play in a much larger system. Honestly, it's a profound paradigm shift. It takes complex, highly technical physics and organizes it into something incredibly accessible and practical. So the crucial point here is this concept of the C element. Think of a C element as a universal storage locker, a locker specifically for effort or force across multiple scientific domains. Think about how a real-world storage locker works. You put something valuable inside, you lock the door, and it holds on to that potential until the exact moment you need it back. Well, in the context of our energy warehouse, a C element is really just any component, regardless of what material it's built from, whose primary shared function is to hold effort and create potential energy. It represents a functional pattern. And here's the thing. Once you understand the mechanics of the C element, you basically hold the master key to unlocking systems engineering across the board. Now let's contrast some different types of storage lockers within this massive warehouse. We just learned that a spring is a C element, meaning it acts as a locker specifically for force. You push on it, it pushes back. It meticulously stores that effort as potential energy. But right next to it, we have a flywheel. Now, according to our source material, a flywheel represents an I element. It doesn't store force. Instead, it acts as a locker for velocity. You literally have to put motion into it to store that energy as inertia. So both are absolutely critical storage lockers in the warehouse, but they're holding completely different types of physical currency. One banks force, the other banks motion. And this brilliantly illustrates the true power of Commander Energy's framework. We're doing a rapid-fire domain hop here. In the mechanical domain, our C element is the spring. In the electrical domain, that exact same storage locker function is perfectly executed by a capacitor. And in the hydraulic domain, it's the tank. It's wild because despite being built by completely different engineers, operating in entirely separate scientific fields, and requiring completely different formulas to even build, springs, capacitors, and tanks all perform the identical role of storing effort. They are all C elements solving the exact same equation. Suddenly, those strict, rigid boundaries between mechanical, electrical, and hydraulic engineering, they really start to blur in the most fascinating way. All right, we're going to pause our warehouse tour right here for a quick thought experiment. Commander Energy calls this the dissipation test. You see, it's one thing to understand the abstract theory of an energy storage locker, but it is another thing entirely to spot it out in the wild. This test is designed to refine our new mental model. It challenges our understanding of what true energy storage actually looks like versus something that simply uses energy up and, well, loses it forever. Let's see if we can actively apply this systems thinking approach we've just built. So, I want you to actively engage with this for a second. Mentally identify the real energy storage lockers among these three everyday items. We've got a battery, a moving bowling ball, and a glowing heater. Think back to the C and I elements we were just discussing in the warehouse. Which of these are actually holding on to power, building up potential or kinetic energy to be strategically deployed later? and which are completely failing that test. Take a quick moment, evaluate the physics of each item, and lock in your answer.
Okay, let's reveal the answers. The battery, that is absolutely a storage locker. It retains energy chemically, just waiting for a circuit to close. The moving bowling ball, also a storage locker. It's actively retaining kinetic energy, rolling down the lane much like that spinning flywheel we looked at earlier. But the glowing heater? Yeah, that was Commander Energy's trick. The heater isn't a locker at all. Actually, it's more like a leaky bucket or an energy thief. It merely dissipates energy as heat, losing it to the surrounding environment rather than storing it for later use. And that strict distinction between retaining and dissipating, that is the fundamental dividing line when you're analyzing how complex systems function.
Let's zoom out a bit. Transitioning from the specific mechanics of heaters and batteries, we arrive at the broader philosophy of our explainer today. We call this the grand unification. By looking at springs, capacitors, tanks, and batteries, the ultimate learning goal of our source material is recognizing these functional patterns across all technologies. Because when you learn to see the underlying pattern, instead of getting distracted by all the individual parts, you become an incredibly adaptable problem solver. You don't have to relearn the core concept of storing effort when you switch from a mechanical engineering challenge to an electrical one. The pattern is exactly the same, and that makes this systems thinking approach a true superpower. This quote beautifully summarizes our entire journey through the energy warehouse. Let this sink in for a second. The medium changes, but the mission remains the same. I want you to really internalize this big takeaway, because it absolutely changes how you look at the engineered world. Whether the medium is cold mechanical steel, complex electrical circuitry, or heavy hydraulic fluid, the underlying physics mission of storage is completely universal. The job of a C element doesn't care what scientific domain it happens to live in, it just does its fundamental job over and over again, across the entire universe. Now, what's really interesting about this is how it applies to you right now. I want to leave you with a provocative thought to bring this right into your reality. Just look around the room you're sitting in. Can you spot a hidden storage locker? Is there a battery in your laptop acting as a C element right this second? Or maybe a high-tension spring in your desk chair, quietly storing mechanical force? By applying these physical principles to the everyday objects surrounding you, you start to see the hidden architecture of energy absolutely everywhere. It's like a giant puzzle you suddenly know how to solve. So keep your eyes open for those invisible patterns, and we'll see you in the next explainer.